Good morning, everyone. Before selecting any pipe for an industrial project, engineers must understand pipe dimensions. Pipe dimensions are much more than simple measurement. They directly influence the safety, efficiency, and reliability of an entire piping system. The correct dimension determines how much pressure a pipe can withstand, how much fluid it can carry, and whether it will properly fit with valve, flange, fitting, and other piping components. Even a small mistake in specifying pipe dimensions can result in leakage, excessive pressure loss, increased costs, or even system failure. For this reason, understanding pipe dimension is one of the fundamental skills every piping engineer must develop. Now let's look at four most important terms used in piping engineering. The first one is outside diameter or OD. This is the actual measured diameter of the outside surface of the pipe. For a given normal pipe size, the outside diameter remains constant regardless of the pipe schedule. Next is inside diameter or ID. This is the internal opening through which the fluid flows. Unlike OD, the inside diameter changes whenever the wall thickness changes. The third parameter is wall thickness, usually represented by letter T. A thicker wall provides higher pressure resistance but reduces the available flow area inside the pipe. Finally, we have normal pipe size or NPS. NPS is not a physical measurement. It is simply a standardized designation used throughout the piping industry to identify pipe sizes. Understanding the differences between these four terms is essential before studying schedule and pressure rating. One of the most confusing concepts for beginners is nominal pipe size. Many people assume that a 2-inch pipe has an outside diameter of exactly 2 inches. However, it is not correct. For a pipe size below 14 inches, the nominal pipe size is only a standard designation. The actual outside diameter is always larger than the NPS value. For example, an NPS 2 pipe has an outside diameter of 2.375 inches, not 2 inches. Starting from NPS 14 and larger, the situation changes. For these larger pipe sizes, the nominal pipe size becomes equal to the actual outside diameter. This standardization simplifies the identification of large diameter pipes while maintaining compatibility with piping components. OD-ID wall thickness relationship. The relationship between outside diameter, inside diameter, and wall thickness is one of the most important equations in piping engineering. The inside diameter is calculated by subtracting twice the wall thickness from the outside diameter. This means that if the wall becomes thicker, the inside diameter becomes smaller, while the outside diameter remains exactly the same. This is why Schedule 14 and Schedule 18 pipes with the same nominal pipe size have identical outside diameters, but different inside diameters. A thicker wall thickness, the pressure rating of the pipe, but it also reduces the flow area available for process fluid. Therefore, engineers must carefully balance pressure requirement, with hydraulic performance. Let's summarize today's lessons. First, the outside diameter is the actual physical dimension of the pipe and remain constant for a given nominal pipe size. Second, the inside diameter depends on the wall thickness and determines the available flow area. Third, nominal pipe size is a standardized identification system rather than a direct measurement, especially for pipe sizes below 14 inches. Finally, the pipe schedule controls wall thickness without changing the outside diameter, ensuring compatibility with fittings, flanges, and valves. Understanding these concepts provides the foundation for future topics such as pipe schedule, pressure rating, fitting, and piping system design. Thank you for your attention, and I will see you in next lesson.